Hello, everybody. Thank you so much for coming today. We've got a big crowd signed up at this one, so we're excited about it too. Sounds like it seemed interesting to the Twitterverse and the LinkedIn universe as well. So thank you so much for joining us, and we will go ahead and get started because we've got a lot to do in an hour, right? So, quick housekeeping. Everybody's muted right now. If you have any questions, please use the questions tool in the GoToWebinar panel on your screens. You can pop in questions. We'll, for the most part, save those to the end. So we should have some time left to kind of go through anything. If we don't get to a question before we all pop off, we'll try and follow up with you afterwards and get that answered. And the webinar is being recorded. So yeah, we've got that. It'll take us about a week to get it out after we're done with the webinar, just so we can clean up anything, audio, whatever. So if you need to drop off or you come in late, not that you'll hear this if you do, but don't worry, we've got it recorded, and you'll also be able to share that with other people in your company if you think somebody else is interested. So excellent. With that, let's introduce our team today. So I'm your MC, Kelly Cohn, and you guys have to listen to me way too much, so I'm not going to go into detail on myself, but we do have Trevor McGough today. Trevor is going to be telling us about the Heron scanner and the processing software that takes that data and gets it ready to go into Edgewise Building and Revit and all the other stuff downstream. Trevor, you want to say hello?
Hello, everyone, and thank you, Kelly.
And Trevor is also our in-house kayaking expert. So if anybody really loves kayaking, Trevor knows all the best spots to go. So wonderful random factoid there. And then after Trevor gets done with the data, Jason Moran is going to take over and will be loading that into Edgewise, running the wonderful automatic extraction tool that now is updated to work with mobile scan data, and then taking that into Revit for us so we can kind of see the whole process. Jason, say hello.
Hello, everybody.
And Jason pretty much does look like this all the time. So, you know, if you see him like this at a conference, he's not angry. That's just, he's very much a Viking.
Yeah, my mom told me my face was going to be stuck like that, and I didn't listen.
Always listen to your moms. All righty. So, again, today we're going to be going over this workflow of taking mobile scans and getting those into Edgewise and getting walls out of it and taking those into Revit and getting to the point of having a nice, accurate floor plan that you can use for all sorts of wonderful things. One of the key things about mobile mapping that makes it so appealing, of course, is speed and efficiency. So because you don't have to set something up on a tripod, level it, push a button, wait 2 or 3 or 5 or 10 minutes for it to take all the laser scans and pictures, pick it up, move it to another location. Because you don't have that. You're literally just walking and it captures as you walk. You can cover 5, 10 times the area the same amount of time with a mobile scanner. And so what we're going to see today is that process, and then we're going to talk a little bit about how the Heron Desktop and Reconstructor specifically help address some of the downsides of mobile scanning, which really come in on the localization and global accuracy side. So yeah, with that, go ahead and pass presenter over here to our Heron tablet. And then we're going to get to see them walk around our office live and capture some data. So Trevor, why don't you tell us what we're seeing right now?
Perfect. Thank you, Kelly. So right now, we actually have the view from the Heron tablet live. So this is where we can live see the data that's coming in as we're walking around the Heron tablet. So a couple little technical specs about the Heron tablet. Number one, it uses the Velodyne 32 sensor. Unique with the Velodyne 32 sensor is it's doing about 700,000 points per second as you're walking around. So just for comparison's sake, I know a couple of terrestrial scanners are in about the 900,000 points per second range. Also, speaking of that range, the Heron does have a range of about 300 feet, 100 meters. So pretty much you throw the backpack on, a single person can do this out in the field, and then continuously just walk around, and then it'll be pulling in all that data. And again, live on the tablet, I can see everything I'm collecting. Colors represent the data as it's pouring into the tablet right here. So as you can see, it's fast. That is the #1 name of the game here. As I'm going through, again, an area like this, I can do this in under, I think we're almost about about 10 seconds of data collection here. So in the same span that the Heron takes me about 10 seconds, with a terrestrial scanner would have to do multiple setups. That would be taking, I don't know, I would say if I was looking at this, maybe about 15 minutes or less than that probably, to do multiple setups. But again, speed, utterly unparalleled. I can just walk the floor, no need for setups, simply walk. Any doors, stuff like that, just simply duck down so that way you don't hit the unit on the door frame on accident. And then again, just kind of keep data collecting as you go through.
Awesome.
And you can see right there kind of the results. And again, full on the tablet. That way I can make sure while I'm out on the field that I have full data collection and again, making sure I'm not missing anything.
Yeah. And Trevor, I'm going to go ahead and make you a presenter now so you can kind of show what happens next. So basically, after you've done this walk, right, you take the data off the backpack, put it on a thumb drive, pop it into a computer. You can also do this on the actual tablet, but today we're doing it on Trevor's computer so he can have his microphone handy. And you bring that in, and it's already partially registered, and you basically go through the process of optimizing it. So show us a little bit about that, Trevor.
All right, perfect. So right here, I've actually just got a smaller section of the data, just again to just for demonstration's sake today. So once we have the data in, I have a little playhead down here where I can kind of cycle back and through and see kind of the data collection. But let's talk about some of that processing and the algorithms behind the scenes that really make the Heron unique. So the first step of our 3-step process is going to be the odometer right here. So the odometer process is where the algorithms we're going to go through. They're going to kind of do an initial smoothing out of the trajectory. And that trajectory is that orange kind of squiggly line that represents, how I was walking in that space. So this kind of helps minimize any drift effects, kind of, again, those intrinsic things that are many kind of mobile mapping solutions, kind of intrinsic to them. In the software side, again, using this odometer step, it allows it to kind of smooth itself out, and any sliding, stuff like that, helps it eliminate. And also, kind of the neat thing that I've found as I've used this is that by checking out the data right here, I can kind of check it to make sure, again, I'm getting a sense of kind of the quality of the data as I'm moving around. All right, so we've finished the odometer step. So now we're going to move on to step 2 of the process, and that's going to be the map creation. The map creation is actually a little bit more of a unique step, and that what the software will do is it's going to go through and basically, for lack of better words, divide up the trajectory and almost treat it like separate terrestrial scans. So each one of these colors, if you can imagine, it's like almost like doing a color by scan or scanner in like a program like Recap, for example. So it's going to divide up that data, again, treating it as terrestrial scans, which really feeds into the most unique process out, and that's going to be the global optimization. So in the global optimization right here, I have these blue linkages as well as these colored dots, and those colored dots represent the kind of individual scan chunks. And again, think of them as terrestrial scan locations, and the blue links represent the registration in between them. So instead of just kind of moving and kind of linking it one by one, I have the option to go here and do a selection, and this is where I'll make cross linkages between all the different, all my different kind of scan setups. The beauty of this is instead of registering kind of one in sequence, I'm using the whole point cloud to get full registration across my different maps to help eliminate and reduce any error throughout the registration process. So we'll go ahead and finish that. I'm just going to call this like a... There we go. And now we're ready for export. So the process right here was in Heron Desktop. Just to save us a little time, I've actually got it already exported out into the next software we're going to take a look at, and that's going to be Reconstructor. So Reconstructor is a really nice software in that not only can it work with Heron data, but it actually gives you the ability to work with pretty much any major set of scan data, any terrestrial point clouds, mobile data. It acts as a central hub where I can bring everything together and kind of work with it. So right here, I've got a little bit of a larger data set. Again, I've already imported. And when we first import this Heron data into Reconstructor, it'll automatically create something called a blueprint. So this blueprint right here is a 2D ortho photo, giving me kind of this automatically generated floor plan that I can then take dimensions off of, calculate areas, and there's also a free viewer that I can send to my clients, again, so that way they can do their own little calculations using this X-ray photo right here. Coming back to the point cloud data itself, we have our point cloud as well as the trajectory loaded in, and this is where I could begin kind of working with it, kind of manipulating the data further. One of the unique things though with the Heron is I can come over here and there is a blueprint navigator, and this gives me the ability to see down here at the bottom. I have my blueprint as well as my trajectory, and I can click on a spot on my trajectory. So let's go maybe right about here. Oops. And then up here I can orbit around and kind of take a look about what I was seeing, as well as if, say, we go ahead and at the bottom of my screen I have a playhead. I can go ahead and play my trajectory as well as kind of look around. And this right here, this kind of video view that you're seeing, this is off the onboard camera that is mounted on the Heron. So I can actually go through and cycle in between the camera data, and as you can see using down here, I can see the point cloud data itself. And this allows me to take any annotations, measurements, notes, and it's full point cloud that I can manipulate with, as well as I can see the image data on top of it. And that, again, especially valuable if I'm trying to show my clients. I have the ability to kind of go into this walkthrough mode where I can walk through, see exactly what I did out in the field. I have both the photo data and the point cloud data backing me up, so I can do any annotations, make any markups that I so wish. And that is a little bit of a nutshell about the Heron software.
And at this point, Heron also has tools to go through and clean out the data. If you've got people walking through cars, you've got all sorts of different tools. You can go and do that inside of Reconstructor. And then you run a basic export. And then you can dump that out to RCP format, of course, or E57 or a number of different industry standards. And then that data is something that you can bring into a host of different applications, of course. So one of the things that I always really like to talk about with mobile data, again, is this kind of, with the speed, you normally get some downsides, and I'm sure everybody watching saw some of this in there. You get much noisier data. The kind of local accuracy of the data is less because you're constantly moving. The second thing that you get is this challenge of drift, so that, as you walk down a long hallway or down other spaces, particularly around curves, or if you don't have a lot of features, the accuracy of the overall point cloud can really suffer with mobile scanners. And so one of the things I think that's really, really exciting about the Heron is there's a couple different mechanisms by which you can control that kind of drift. So you can, of course, you do control points. One of the fun things is you can literally set the scanner on a control point out in the field, and then you can bring that in and it will actually update the trajectory. So it's not just getting the point cloud into the right place, it's actually updating the path and controlling that drift. And also very cool if you happen to have terrestrial laser scanners as well already in your scanning arsenal. If you have geolocated or on survey control scan locations, you can bring those scans into Heron Light, and then you can actually use those in part of that mapping and global optimization process. So again, it will actually update the trajectory and bring all this mobile data tied into these terrestrial scan locations that are on control. And so those two techniques can basically eliminate the drift that you really struggle with mobile scanners doing much longer captures. So that's really cool because it gets you good global accuracy, which has always been a challenge for mobile scanners. And with that, though, let's talk a little bit about what comes next in the process. So after we get the data out, we want to bring this data, of course, into something like Revit. And we want to get walls, and we want to get doors, and we basically want to get our floor plan, right? So that noise, that local noise that you saw, where the wall might be a couple centimeters thick in the scan data, this has always been one of the other downsides of mobile scans, because there's nothing you can really do to get rid of that noise entirely. And so it just makes it a little bit tougher. Anybody that's modeled with terrestrial laser scans and also modeled with mobile scans, it's much, much harder to kind of manually trace and draw geometry from mobile scans because of that increase in the noise. It just takes a lot more time. You have to do a lot more interpretation. And so this is one of the exciting things for us. We saw a real opportunity to take our Edgewise product, which already could extract walls from terrestrial scan data, and then apply it to mobile scan data where it's really even more valuable to be able to do this. So let me go ahead and make Jason presenter here. If I can do that successfully. There we go. Excellent. And Jason's going to basically walk us through that process of taking the exported data and running it through Edgewise and then pulling it into Revit. And we'll get to kind of go over all those optimizations and changes we've made in the last couple months. So,
excellent. Thank you, Kelly. So what we see here is the new update to Edgewise building. What I have loaded in as a point database already is the Heron scans that Trevor was just showing in Reconstructor, already transferred to my computer, of course. And like Kelly said before, Edgewise only supported terrestrial data. We would work with static scan positions. You would bring all the scans into Edgewise and you could process it that way. But process scans in Edgewise has gotten a bit of an expansion. Now, in addition to those structured scans, we'll support unstructured scans, which are going to be even more typical of indoor mobile mapping systems, structured light scanners, things like that. And we can also run extractions on pre-existing Edgewise point databases, which is kind of a handy feature for maybe any existing projects our Edgewise user have. Since I already have the point database loaded here into Edgewise, I can simply proceed with the database workflow. And I can begin to set parameters for my wall extraction. We have parameters here for distance between levels, which is, of course, one of our new parameters or one of our new features in the automatic extraction, as well as wall extraction tolerances that allow us to basically tell Edgewise how fuzzy or how noisy we think the data is going to be and adjust it that way. I'm going to leave these at the default for now and just hit next. And Kelly, why don't you tell us about kind of the reasoning behind this update, some of the behind the scenes stuff.
Yeah. So the we announced this at our user group a couple months ago. Actually, gosh, it was like 6 months ago at SPAR. And one of the things that we really saw was a great uptick in interest in mobile scanners. And so, for a long time, there'd been a couple of these out on the market, and the efficiency you could get out of them was incredible, but the kind of output that people were seeing just wasn't quite where it needed to be for people to get really usable, accurate results. So it was, one of those technologies that looked really promising that wasn't quite there yet. And the last, about year or so, there had been a bunch of new ones that had come to the market, which were showing, much better local accuracy, some initial enhancements for the kind of global accuracy problem, and we were definitely excited about this. And then we bumped into the Jexcel guys at a conference, and they were showing us this, and then they ticked off that last box for us, which was that overall global accuracy problem by showing us some of the control point workflows and being able to use existing scans and actually even 3D models, which is an interesting workflow. Not necessarily the most accurate one, but a very interesting one, to be able to manage and control this kind of this global drift that's always been a problem. And to us, this seemed like a real opportunity because we knew the problems users had with this data in terms of the kind of noisiness of it, and makes it a little bit harder to model with. But for an algorithm, they don't care, because that noise is still statistically, distributed, right? Which means it's not biased one way or another. So, for an algorithm doing a mathematical computation, whether there's 4 centimeters or 2 centimeters or 1 centimeter, finding where the face of that wall is, it's not really that different. For a person, that's much harder with 4 centimeters or, 2 centimeters than it is with 1 or ½ centimeter. So it really gave us this opportunity, I think, to take some algorithms that we had, modify them to work with mobile data, and really take advantage of that incredible field efficiency you get with a mobile scanner, but still being able to deliver good, highly accurate results in terms of the final deliverable to a client in the form of a building information model. So that's. Did I miss anything, Jason?
No, I don't think so. That about covers it.
Yeah, I mean, basically, we wanted to show mobile scans because it's it's very fuzzy, and it is, after all, no shave November, right? So fuzzy data is good right now.
That's right. That's right. This is going to take just another minute or so to process, but let me just switch over to a finished version. Basically, this is the.
You mean you don't want to watch that last 1 minute of progress bar?
No, I do not, Kelly.
That's so exciting.
So what we're seeing here is the point cloud. I can turn that off and we can look at just the results of the wall extraction algorithm. So any more experienced Edgewise users out there will notice some key differences from this to the older version of Edgewise building, namely before Edgewise would create some planar surfaces, and you have the option to pick levels from those surfaces and then click find walls, and then it would process for a little bit and find the actual walls from the surfaces. Here, that process is completely automated. So we basically select our scan or our point database like I did just a moment ago. We hit go, and what we see is walls, levels automatically extracted with no manual interaction necessary to pick those things out. Of course, I can still manually define levels, adjust the length and thickness and position of the walls, but the starting point is much closer to the finish line than the previous version.
And I'm sure people will notice that not every wall is closed. There's a couple gaps. You may notice there's a couple weird angled walls where a door panel was basically the same height as a wall, so we picked up the door. So again, we always like to say algorithms aren't perfect, but they, our aim is to give you a massive head start. And this, as you can see here, we get a majority of the walls. They're precisely as built, with very fuzzy data that's coming out of a mobile scanner as opposed to a terrestrial scanner. But this is with really just a couple minutes of checking boxes and clicking buttons, and you're a long way to having the kind of basis for your floor plan already done.
Yep, that's right. So I could spend, a few more minutes in here fiddling with the ends of my walls, making them line up nicely. But what's a lot more interesting, and I want to spend some time talking about, is the kind of new and improved Revit import options that we have that will really transform, this transforms the starting line of detecting walls from, a point cloud. But our new Revit options really transform the process of transferring that into a kind of a useful and deliverable Revit model. So let me bring up Revit 2020, and through the Edgewise Import tab, I can select my export file, bring it in, and we're going to see kind of this huge dialogue that you're not going to have found in previous versions of Edgewise, and this gives us some really interesting controls. Kelly, I know you're kind of a Revit aficionado. Do you want to kind of dive into this a little bit and talk about the goals here?
Yeah, sure. So, one of my frustrations back when I was a user was that the wall tool was so exciting because it would get all these kind of fragments of walls and get them almost there, and then you'd bring them into Revit, and it was frustrating and disappointing, just to be honest, because walls would be at this crazy angle. Everything was down to like 0.000000001 of a degree or of an inch. It was a truly as-built model, which of course anybody that's ever tried to do any documentation in Revit knows that that's like the worst thing possible because you will now have trouble putting in dimensions and all this other stuff. So we really spent a lot of time with this release thinking about how should we make that translation from as built to kind of that as intended, or that rationalized state. So, for starters, we wanted to make sure we got the overall orientation and location right. So if you don't already have shared coordinates set up, right, we can actually bring it in and we can set up shared coordinates for you, and that includes setting rotation to true north. So our software will kind of find the primary ordinate dimensions of your project by looking at all the walls that it extracts, and it will set the rotation to true north so that those walls come in at 0 and 90 degrees relative to project north, which means it'll actually show up right in your documentation.
That's if the shared coordinates are not set up already, right? If I've already configured those and it's a pre-existing Revit project, Edgewise just respects that and it doesn't try to move it all around based on the import.
Absolutely, absolutely. And we also get the elevation. We let you set the level mapping so you can decide which at level in Edgewise comes in at what elevation so that it matches up with a level you already have in Revit. And then we do some really great stuff with angles and merging. So for instance, if you already have a couple stories of your building in Revit and you've got those set to nice even dimensions, if Edgewise has found a level that's very close to that, you set the tolerance. It will basically use that level instead of creating a new one. And then we'll handle rotation in a kind of a two-stage process, right? So if it's a primary dimension, so if it's on 0, 15, 30, 45, et cetera, if it's on a 15-degree increment, you can set an angular tolerance and say that I want any wall that's within 2 degrees of one of these primary dimensions, just draw it at that primary dimensional angle. We will find the kind of best way to do that so it stays as close to the point as possible, but we'll draw it in to match that angle. But you can also kind of set a limitation because, of course, a short wall, we can move the angle a lot and not move it very far from the points. A long wall, if we change the angle even a little, it can have a big impact. So if you have like an LOA specification from US IBD that says you need to be within a 1 inch or 2 inches of the points, you can actually type that in, and any wall that moving its angle will exceed that dimension, we won't move it that much, and we'll actually fail over to our angular rounding, and basically any wall that's left, we will try and round to whatever angular increment you set. And then we'll kind of stair step down.
This is something we probably spent way too much time internally arguing about, is whether an angular tolerance or a displacement tolerance was superior and in what conditions. So people will notice these check boxes here next to angular and displacement. And I can actually uncheck one or both or the other of these, and Edgewise will only use that tolerance or the tolerances that are active when making these rotation decisions. So if I want to rotate every wall within 5 degrees, regardless of the displacement of the endpoints, Edgewise will absolutely do that. If I only care about the displacement and I don't care about the angular distance, then that's fine as well. And if I don't want to do any of the rotation, that's an option too. So it's kind of straightforward in principle, but incredibly robust in terms of how much control you get over exactly how the walls are adjusted and when they're adjusted.
Yeah, and then we do something similar for dimensional snapping. Of course, nobody wants to dimension between 2 walls in their hallway and see, 3 foot 11 and 429 5/12 of an inch. So likewise, when we're placing any of the orthogonal walls, we can snap those basically to almost like on grid paper, right? We can basically snap those to an increment. And you also get to set wall thickness and control whether or not wall joints are allowed. So super robust. Again, this has always been a challenge when you work with any of these extraction tools, is getting stuff that's too accurate to use for actual documentation. So, it's a big long menu, but it basically lets you dial in everything you need to get the kind of level of accuracy that you've got to have, but, while still getting some amount of rationalization in place to make it easier. So, oh my gosh, let's click next.
This is one of those dialogues that it takes longer to explain all the little controls and all the power it gives you than it does to just hit go and look at the results, right? All right, so here we have basically exactly what I had in Edgewise, at least at the surface level. If I start to draw dimensions between things, we will see exact 90-degree angles where maybe it was 89.48327 and on and on and on, as observed by Edgewise. The same is going to be true if I dimension between two walls here.
Look at that, nice 3/4 of an inch.
Yep.
And you'll notice that it's if you looked at this in Edgewise, it was at some crazy random angle based on where the scanner started, right? But obviously here it came in nice and orthogonal to the screen.
That's right. Of course, this helps us with with the walls themselves. They're all kind of idealized between the way we want to kind of document or report this model versus what the scanner observed. But we also need to worry about wall-hosted objects like doors and windows, and we need some tools to assist us in modeling those. So this is a feature that's been present in Edgewise building for some time. Let me switch to wireframe view just to set myself up here. In addition to exporting the walls, we also store the point cloud data for each wall in the export file. So I can select a wall and I can color it based on its distance from the point cloud on a per point basis. Of course, since this wall has been adjusted based off of those kind of rotational and displacement tolerances, it's not going to fit the point cloud perfectly. Like we've been saying, the goal is to control, basically balance the as-builtness and the idealization of it to come up with something deliverable. But with this, I can look at any objects on the wall, whether they be doors, windows, that kind of thing, and begin to model those. We can also see how the rotations and adjustments that were done in the import process actually affected the model as well, if we're curious. We have some analytical tools.
And at this point, if we want to finish this out, we would basically go through and trim up the walls that are not quite connecting. We've got some glass walls in front of some conference rooms, for instance, that of course aren't going to be picked up in a laser scan. But we go through and trim all that stuff up, start dropping in doors using this tool. And the nice thing about that is we don't have to load all the point cloud data. So if you're on a computer that maybe can't handle point cloud data quite as easily, this gives you a much lighter way to access what you need to place the components on that wall.
That's right. Of course, in addition to having the analytical view of each wall, over the last few years, we've added some really great kind of point cloud segmenting tools into Edgewise, which we call smart points and remainder cloud. So I can bring in basically the smart points for this model, and that's basically all of the points that belong to kind of the modeled objects in Edgewise. So if it's modeled in Edgewise, we basically gather up all the points around it, and we export it out to its own PTS or RCP file so that you can bring that into Revit or into another tool and use that to assist the rest of the modeling process, because Edgewise is great at walls, it's great at pipes, it's great at structural objects, but even with everything we do, there's a lot we don't do, but we still want to assist you in modeling that stuff. So I can load up the smart points here, and I can see very clearly the colorized points on all of the walls and everything that's been modeled in Edgewise.
So yeah, why don't we, while we kind of start pulling up, looking at some Q&A and everything else, I don't know, Jason, if you want to hop into a plan view and maybe trim up some stuff and drop in a couple walls just for fun.
Sure.
Way we can, actually fulfill our promise to get a floor plan done by the end of the hour.
That's right.
But why don't we go ahead and take some questions while that's happening, because I think that's more fun to watch while we do Q&A than my slide is. So let's start looking at these questions. And Trevor, go ahead and unmute yourself in case we've got any for you. Let's see. Right. Oh goodness. Not that this is super relevant, but Trevor is a rock star. So Trevor, you have a fan, Neil Wakeman. So
Thanks, Neil.
All righty. So Chris Scholl has a question about complex line of sight scenarios. Will this unit help with that? So the answer is any mobile scanner, one of the advantages is since you're constantly moving, your coverage tends to be much better than you get with a terrestrial scanner, because the line of sight challenge is the fact that it's stationary while it's capturing all this data. So in the case of these conference rooms, you might have done maybe 2 scan setups in those conference rooms, one on either corner of the table, so that you get most of the floor, right, on all the sides of the table. But unless you set the scanner really low and get all the chairs out, you're still going to have a big shadow underneath the table, right? But by kind of walking around with a scanner, since you have literally hundreds of kind of scan locations as you walk through the room, typically you will see that line of sight is much less of an issue with mobile scan data. The Heron also, you can actually put the scan head on a little monopod. So if you're in a place where you need to, for instance, stick it up above a ceiling tile, pop some ceiling tiles and you want to lift that thing up high and get it above the ceiling tile, or put it underneath something, you've got a lot of flexibility. It doesn't have to be mounted onto the backpack, though that's super convenient when you've got a mile to walk. Great question. All right. Excellent. So Gus Rios has a question about comparing static scanning with mobile. So we've done a lot of comparisons, Gus, and the short answer is no, you are not going to be able to extract smoke alarms, light switches, or electrical outlets looking at mobile scan data. The local accuracy is just not there. So if you're trying to get down to that level of detail, you still need to use a terrestrial scanner, full stop. Just the technology is not yet at a point where that local accuracy, the resolution on a surface, is good enough that you're going to be able to clearly see small features. Hate to break it to you, that's the case. So this is a solution that's really good for people that need to get walls and doors and basic floor plans. So if you're a huge company and you've got millions of square feet of assets and you need to document what you actually have in place so that you can do space planning and leasing calculations and things like that, it's a phenomenal tool because the overall accuracy is still quite good. It's just you're not going to get tiny little bits and pieces and bobs and things on your surfaces. So just something to bear in mind. But it's not a replacement for a terrestrial scanner. It serves different purposes. All right. Chris Scholl again has asked, do you need to walk through a space multiple times to ensure full data capture? So to get coverage, Chris, you probably only need to walk through a space once. If you've got a complex space, this has kind of got almost like a double L-shaped hallway. It's nice to be able to overlap paths that you've already walked for accuracy, because when you do that global optimization that Trevor mentioned, having those overlapping paths will help control the overall trajectory and get you that nice global accuracy. But in terms of within an office space, if you need a little more density, you can walk more slowly. So the faster you walk, obviously, the less points you'll have in a given space. The slower you walk, the more. But you don't generally need to go in and walk the same space more than once. All right, let's see. Neil Wakeman asked, Rob, how does this handle stairwells for multiple levels? So we have found that it works pretty darn well. Again, the tracking on the instrument is, it's tracking live as you walk. And so it knows when you're changing elevation pretty accurately. What I would say is that it's on its own, it suffers from all the same things that any other mobile scanners will suffer from at the hardware level, in terms of drift and maybe not quite getting your floor-to-floor elevations correctly. But this is where control points can be really useful, because this instrument, and again, that monopod that I was talking about, if you have it on the monopod, you can set the monopod on a control point, and then you basically kind of move it around in a circle, almost like you're, stirring a cauldron. I mean, we're still close to Halloween, so we can make cauldron jokes, right? So basically, you stir it around like you're stirring a big cauldron, and that kind of signals to the instrument. You can tag it, and then you know now that that control point relates to an exact XYZ coordinate space from a survey control file. And so just by doing that one little thing, you can basically correct any of the error that you would get from drift going up or down stairwells or going through long hallways. You can basically pull it back onto a good control, and again, get that really good global accuracy that this instrument can deliver. Let's see. Do you need to have control points to align with an existing building? Trevor, you want to answer that one? If you're unmuted.
Yep, there we go. Took me a bit to find the mute button there. So depending on what workflow, the key thing with the aligning for the, if you're trying to do the change detection, basically import an existing model, say from Revit, no. Part of the unique thing is the algorithms themselves. The Heron itself can, I won't spoil it too much, but it can look at the model, and then you can kind of help it out a little bit. And at that point, the algorithms will actually lock on to where it is. And then at that point, you can basically continue on scanning, and the existing scans will align themselves to the model that you've loaded in.
Yeah, so there's some really neat workflows, and again, if we showed them all today, we wouldn't get done with the plan part. But but the wonderful thing about this instrument is there are many different ways to get the scan data to kind of align and correspond with either pre-existing scan data, building control, 3D models. So they've really spent a lot of time looking at that particular problem and actually doing a very good job solving it, which helps out a lot with these kind of conditions. I think we've answered a couple of these other questions just by virtue of it. Photo data going to be blurry. So the photo data is relatively low res data, and it's a video. So if you ever pause a video mid-frame, you'll notice that every frame is a little bit blurry. So it's actually doing a video. It's not taking photos like you do with a static scanner. So since there's motion, you're not going to get the same quality of photo that you're going to get out of a stationary instrument that's sitting there perfectly still while it takes a photo. That is the kind of quality that you get. The faster you walk, the blurrier it gets. The slower you walk, the less blurry it is. But that's just kind of a constraint of the technology. We have a question of international or U.S. survey feet. Trevor, do you happen to know that answer off the top of your head in Reconstructor? Can we set units to be those things, or is it always operating in metric?
So it is completely ability. You can set the units to whatever you'd like. I actually just had this the other day, so I'm very familiar with that. But yes, it's completely, if you want to operate in survey units, or you can operate in international, completely up to you when you define your project settings.
Yeah. All right. And we actually, Gus Rios has asked a series of questions. Did you compare how long field to finish would take between a manual approach versus using the algorithm? So we are still actively testing that. What I'd say is that our general observation so far is that in terms of the office modeling time, if you're in a small space, you get a little bit less of a benefit. So you don't get a huge time savings over kind of manual hand drawing. I would say that the big difference on small spaces is accuracy. So again, with mobile data, if Jason wanted to zoom in on one of these walls, with mobile data, the fuzziness that you see on the surface kind of makes it pretty hard to really know exactly where to draw the wall. And so you end up spending a fair amount of time kind of trying to optimize, how thick is the wall, where do I draw it, where do I put the location line. If you don't need a very accurate output and you don't spend that time, then what you're turning over isn't really comparable. But to do a really good job, on a space this size, in terms of manual versus using the automated extraction, you're operating, it's still going to be roughly twice as fast to get this head start. If you've got a large space, what we've seen is that you really get to start to see a lot of dividends with much larger spaces. So the bigger the space is, the bigger the payoff is in terms of the office labor. And of course, the benefit is for the overall solution, because today we skipped a couple of progress bars, like we didn't hit the export button, which probably takes 30 or 45 seconds. And we didn't let the last minute of the progress bar finish for the wall extraction because I ran out of steam. But but really, this floor plan, to get a really accurate really accurate representation in plan with walls and doors and just get everything dropped in, you really can crank out from running the scan, doing the processing, finalizing the registration, exporting it, loading it in. It's a lot of button clicks, but in an hour, you can have a floor plan for office space this size. And trying to do that with a terrestrial scanner is just not even in the cards. You're talking at least a day to kind of crank through this whole process. So I would say, when you compare it to that, there's a huge time efficiency. And I would also say, if you turn over scan data to your clients, it's really tough turning over mobile data because that fuzziness, I don't know, I think it just makes people nervous, even though you can say, hey, the statistical average of the data is still highly accurate. When people see that, I think it just makes them nervous. So it makes it a little harder to use and harder to come to a decision on. All righty. We've got a question about, do we support NavViz scanners? So Edgewise Building will work with, actually, hey Jason, tell me the formats that Edgewise Building will read in.
Sure. Right now we're working with E57 files, PTS and XYZ for kind of the unstructured side of things. So not just NavViz scanners or whatever other mobile scanner you want to use. I know there's a lot of questions here for it, but pretty much anything that can create a PTS or XYZ file is technically compatible with the algorithm, which is pretty exciting.
We've actually, we did a little testing, for instance, with Matterport, and had pretty good results. We're still experimenting with that a little bit, but
that's right.
Yeah.
Yep.
So yeah,
photogrammetry. Even technically, even maybe drone data. But I'd really love to see the accuracy, the density, the quality of that data before promising you'll get great results with it.
Yeah, that is a challenge. So yeah, the algorithms will work with unstructured data in those formats, and pretty much anything we've run into will export one of those three formats. So you should be able to use it with anything if you've already got one. Let's see here. Other scannables. Okay, that answers that. I think we answered that. Can you utilize targets in the Heron software to align the point cloud to a local UCS? And the answer is yes, there is a way to do that. I think we were on a call with him today taking a look at that workflow this morning. So that's a definite yes there. Is there a way to clean up the walls in Edgewise rather than Revit? So we have some tools in Edgewise to go through and modify the walls a little bit. But there's definitely a lot of robust wall editing and modification tools in Revit that we have not chosen to replicate on the Edgewise side. So you can, Jason's got them here. So you can certainly delete walls. Normally what I tell people is if you know there's a wall that's obviously something you can quickly delete, do that in Edgewise first. You can adjust the ends, move walls around, get things to trim up a little bit. So for those kind of modifications and edits, those are great to do on the Edgewise side. And then you basically pull it into Revit, and any kind of more robust stuff, cutting openings in them, so all that kind of stuff you're going to do on the Revit side. All right. Okay, we have a question. Is this full ClearEdge Edgewise, or is this a special module for wall extraction? This is from Johnathan Hopfer. Johnathan, the answer is this is part of the Edgewise building, so this is an upgrade to Edgewise. So if you own Edgewise, the full suite, and you have Edgewise building, when we push this update up on the website in a couple weeks, you will download it and you will have it. But we are offering this as a special bundle with the Heron scanner. So, so if somebody is really interested in having these two things work together, we basically have an isolated version of just the Edgewise building suite and the Heron that we'll package up and sell together. Okay, what static scanning data does the Heron software support? Hey, Trevor, so for bringing in a terrestrial scan into a Heron desktop or through Reconstructor, what are the formats that it can import as a basis for doing that, that kind of localization and optimization?
Pretty much it can take anything. I think the only file it can actually not take is the PTG files. Otherwise, it can take Faro data. It can actually take the raw Faro projects, like right off the scanner. It can take ZNF projects. TopCon, again, it can pretty much take it all, except the one file format is like a PTG file.
But they do support PTX and PTS.
Yep, PTX, PTS, E57, structured and unstructured E57s. Like I said, pretty much all, yeah.
Yeah. We have lovely laser Larry Kleinkemper has asked a question. Can we set a distance for the smart points? And so yes, the answer is with the smart points, you always set a distance of how far away from the surface you want it. And that will either clip, you'll see here, insert smart point cloud export. You can set how far away you want it to be. So up to a meter, all the way down to a couple millimeters if you really want to be very, very tight about it.
That's right. I used 2 inches for the export we're seeing here.
Excellent. So we've got a question about, for a 200,000 square foot floor plate, is this scanner viable considering drifting? And so the answer is yes, particularly if you have control points or if you have a static scanner that you can set on a control point. So I mean, the beauty of it is, right, is because you can take control points and static scans into the calculation of the trajectory, this scanner, when you do that, this scanner basically does not suffer from drift the way that any other mobile scanner is going to be suffering from, because that trajectory gets updated with something else that does not suffer from the same kind of drift. So as long as you've got control points, 1 million square feet, it's not a problem. If you're doing 200,000 square feet and you have no control points, there's a lot of techniques you can use with mobile scanners to try and minimize drift. We'd be happy to talk you through those kind of offline. But so there's certainly things you can do to make it more viable in a large space, even without control points. But if you've got access to a surveyor who can set a couple control points, you can basically get rid of the problem. We have worked with NavViz data, Dennis. We've tested that, and it works quite well. Goodness, lots and lots of questions. I don't think we're going to get through them all. That's awesome. Jason, how are you doing out there? Look at that. We've got doors going in and everything.
That's right.
All right. SLAM software, yes. So again, with when you bring in static scan data or control points into the Heron desktop software, it will actually take that into the SLAM calculations so that you end up with both geolocated or at least control located data and more accurate trajectory that does not have the same drift problems. Okay. And let's see, Johnathan Hopfer again requested, because of the local accuracy issues, is mobile mapping mostly best for creating floor plans? And the answer is yes. So again, this is a specific use case thing. We're not trying to sell anybody on a mobile scanner that's going to let you go around and pick up, conduit or piping, small gauge piping, things like that. That is not what this tool is useful for. But if you have, say, for instance, a 1 million square foot project and the client's primary interest on most of it is, where are the walls, where are the doors, where are the windows, where's my, basically, how is my space laid out? What have I got in that space? Give me general assets, right? And then they've got a couple areas that are maybe mechanical rooms or places where you need much higher levels of detail. The beauty of it is you can basically combine these two things together. So you can take a terrestrial scanner out there for the areas you need higher accuracy. You can go out with your mobile scanner and do that to do your kind of mass data collection. It's also really nice because, I know when I used to scan interiors of buildings, as a default, we would always scan the exterior, even if the client didn't want it, because that kind of gave us the ability to have this overall control. The exterior scans, you did a lot less of them, and you could stitch them together, and that way you could really easily see if you had registration issues inside the building. But that took half a day or a day, just added on that we did as kind of a quality measure in the field. With a mobile scanner, you can basically walk the exterior of the building in 5 minutes, and you've got that data. So there's lots of really nice things you can do in terms of your general data collection where you don't need that very precise localized detail. And then you combine the two together and use them where they make sense. But they're both very complementary technologies. Mobile scanning is certainly not at the point where it replaces a terrestrial scanner for those kind of detailed use cases. Follow-up, how fragile is the device? I hope nobody from Juxel is listening, but I did run into one door frame while I walked with it, and it worked just fine. So,
mind if I chime in with this one, Kelly? So the device actually comes in 2 different versions. The one we had shown today, but they also make a rugged version, and the rugged version is self-contained in a Pelican case. And that's actually pretty heavy duty. Comes from their background where they wanted a device that would be basically safe and able to operate in mines for scanning mining tunnels. So overall, if you walk into a door frame or two, again, it'll be fine. But if you do have a need for a more rugged, they do make a more rugged version of the device.
Excellent. Let's see, I think we are just butting up right on time here. Let's see if there's any one last question I want to squeeze in here.
I see one about the processing time for walls and piping and edgewise.
Take it.
And the new update, we've made really no changes to piping. This is a very building-centric update, but the new and improved wall extraction algorithm that we showed at the beginning does seem to have some significant processing time improvements over the old one. We're still kind of fine-tuning things for the release, so I don't want to promise a specific performance increase, but we're seeing significantly improved performance, especially on larger projects.
Yes, much faster on larger projects. The old algorithm was particularly slow when you had hundreds of scans to deal with, or lots and lots of data. So much faster. Let's see. I think one last question: can I rent the scanner from ClearEdge? So yes, we can rent the scanner. So we sell the scanner and the software as a bundle. We also rent the scanner and the software as a bundle. So if you want to try this out on a job and kind of validate it and see how well it works in your processes, you don't have to go out and buy the entire scanner bundle and just go for it, right? Let us know. We're happy to rent it to you. We've got Trevor can help train you on it. So we'll hold your hand through the whole process to make sure that that everything is working lovely. So please yeah, please reach out to us if you have any questions. Thank you guys so much for listening in and all the wonderful questions. And we will be in touch with you guys soon. And come see us at AU. Oh my gosh, I almost forgot. Yes, we are, of course, going to be at AU. So if you want to come and see this whole thing live, again, then please come and see us at Autodesk University. So we will be right near the kind of AEC hub, really easy to find. We also have our user group at Harrah's on the 18th on Monday from 1:30 to 4:30. So if you are a ClearEdge customer and you want to come to the user group, or if you want to be a ClearEdge customer and want to come to the user group, reach out to us and we will we'll get that info back to you. So cheers and thank you all. Hope you had a wonderful lunch and have a wonderful rest of your afternoon.